Vet and cleanup as usual. We're on day 585 since the evacuation order was issued. This is how I start every meeting, BRC, whatever, so we don't forget how long you folks have been impacted. I'm up here tonight just to answer all the questions. I did break my back. I am wearing armor tonight, so I'm ready for almost anything. I can't run very fast, but the doctor tells me in 3 or 4 months I'll be able to wrestle with my grandkids again. So I'm going to talk tonight about the sinkhole, talk a little bit about cavern conditions, go through the seismic events, and then talk a bit about the gas. The sinkhole is still growing, and just for clarification, we're talking the difference between the minus 10-foot contour in the bottom of the sinkhole. We're calling that the main sinkhole, and then the area between the minus 10 and minus 2-foot contour, that's what we're calling the subsidence area. And so we're showing the main sinkhole in red. This is from the February sinkhole survey, and the subsidence area around it is the yellow line, and this is what Nick was talking about, is certainly across the south berm. Ongoing subsidence monitoring level surveys still show that the southwest corner of the old berm, the old south berm, is still an area that is still subsiding. It just got some new data today, so that area is still slowly subsiding. Next slide. Oh, before you do that, the minus 205-foot depth was the Miller survey. John went out a couple weeks ago and measured at minus 260 feet. So we're seeing it'll kind of fill up a bowl, and then it'll develop what we call the witch's hat, where it develops this higher area. When it develops that witch's hat, that's sediment flowing down through the disturbed zone. So we've seen this pattern over and over here.
Yeah, flow directly into it.
All right. Hello? Says the battery's dead.
Oh, really? Take it, John. It is. It probably is dead. John, can you talk loud enough? I'm gonna go get a wired mic, but you have to talk loud enough. I'll be back.
Okay, I'm going to have to talk loud enough, folks. Anyway, here is the sinkhole volume and subsidence area. On the right side, or viewer's left side, is the volume. The volume of the sinkhole and subsidence area is now up to about a little over 3 million cubic yards. And I'll compare it to the cavern here in a minute. The sinkhole area is still growing, but the rate of growth of the sinkhole area has slowed down markedly. As you can see here on the green line, right there, the growth of the sinkhole, that's minus 10 feet below, has slowed down. And as you can see up here, the growth of the subsidence area has also slowed down markedly in the last 6 months. So things here are trending towards a more stable condition than they were last time we met 6 months ago. And I'm going to show you some other data that supports this. So the sinkhole is not growing near as fast as it was, and the subsidence area has slowed down a lot. The other thing we've looked at is everybody wants to know how big is the sinkhole going to be. So DNR commissioned Itasca to do some modeling of the sinkhole and the subsidence area around it. And the yellow line on here is the current subsidence area. The green line is the Itasca modeling, showing the minus 4-foot contour that couldn't model down to minus 2 feet because of the size of the model, but it shows that essentially the sinkhole growth is slowing down markedly, and I'm not saying it's stopping, but the model indicates that things are headed in the right direction when it comes to the sinkhole. On here also are the dimensions of the sinkhole. It's the main sinkhole is about 1,500 feet across in the northeast southwest direction, and it's 1,600 feet across in the east-west direction. The main sinkhole covers about 30 acres, and then the subsidence area covers another 20-some acres. Okay? The cavern fill, we've talked for the last 18 months that filling up the cavern is the first step towards stability. The hard tag, Texas brine goes in every 2 weeks, tags the fill. As you can see, the solids interface for about the last month and a half to 2 months has been right at the top of the cavern. Top of the cavern is the gray line, and you can see the solids interface is near the top of the cavern. So this is consistent with the slowing down of the growth of the sinkhole, and I'll show you the cavern pressure here in a couple minutes. So when it comes to stability of the cavern and the sinkhole, things are getting better. One question everybody asks is, how does the volume of the sinkhole relate to the volume of the cavern? Right now, comparing apples to apples, accounting for the fact that the cavern was brined for about 18 months after the last sonar, accounting for everything, the sinkhole volume is about 65% of the cavern. Now, people have talked that the sinkhole volume has to equal the volume of the cavern. That's not necessarily so. Some of the Itasca modeling shows that the sinkhole volume may be smaller than the cavern volume, depending how big the disturbed rock zone is. Last time we met, Don Marlin outlined the disturbed rock zone at a fairly large volume of rock, which is going to mean that the sinkhole will tend to be smaller. So things are moving in the right direction. Next. The tubing pressure in the cavern, which is the orange line. Don't worry too much about the blue line. The blue line is the casing pressure, and that includes gas and hydrocarbons, so it's much more difficult to interpret. The orange line is the one you want to look at, and you'll see in the last 4 or 5 months, basically since the last big seismic event, the tubing pressure has started to go down, and in the last week or so, it has dropped markedly. We don't know exactly why it started to drop so fast, but less pressure in the cavern and in that well is another good thing with regard to stability. So things are all pointed in the right direction. Micro-earthquakes, this is the entire history of micro-earthquakes. Starting over on the left side is when the sinkhole first appeared. These are the number of micro-earthquakes every day. And you can see there were quite a few just before the sinkhole appeared. Those are the blue lines. The red lines are what we call the VLPs, very long period events. Those were actual fluid movement going down out of the bottom of the sinkhole, essentially. And you can see here that we've been through a number of periodic events where we have a lot of micro-earthquakes. The sinkhole goes to a Code 3 status, which means no work. And in last October, and then starting in December, we had 2 very big seismic events. Rock was moving somewhere down below. You will notice in the October event, right afterwards, the very long period event stopped. So whatever was causing the VLPs, some rock moved around and shifted, and the VLPs essentially are no longer observed out there. So again, we had 2 big events, but since then is when the cavern pressure has started to decline. The cavern has filled up essentially near the top, and the sinkhole growth has flattened out. So all this is telling us a good picture with regard to stability. Moving on to the gas. Unfortunately, we've got a longer way to go on the gas. You can see here, these are the active sites. We're showing the bubble sites, we're showing the vent wells, we're showing all the CPTs and MIHPTs. And I put this in here mainly so when you folks download the PDFs, you can take a closer look at what's where. The bubble sites are still defining the gas area next.